This second set of videos is going to cover problem solving using formulas. The goals for this chapter are to solve problems with measurements and consistently express results with correct significant digits, use a systematic approach to problem solving, and analyze problems using the problem solving method. Before we can talk about problem solving using formulas, we first need to discuss what are formulas. A formula is an equation usually expressed in variables, which are letters and numbers. So here we have a formula: x is equal to x sub I plus v sub I times t plus 1/2 at squared. And you can see that in this formula we have both letters and we have some numbers. And what we're going to talk about now is how we can use algebra to rearrange to solve for a different variable. One thing that we definitely need to watch out for are the order of operations. More specifically, when we use algebra to rearrange, we have to use the reverse order of operations. So that means that we have to undo any addition and subtraction first, then we have to undo any multiplication and division, then the exponents, and then finally we need to get rid of anything within the parentheses. What we're going to look at now are a couple of examples of rearranging some different formulas. Our first formula, we want to solve for a. And we have x is equal to x sub I plus v sub I times t plus 1/2 at squared. Now before we start rearranging this formula for a, I do want to mention something about the subscripts, so the little I there and there. A lot of times in physics, subscripts are used to represent initial or final. So in this case, x sub I is your initial distance, v sub I is your initial velocity. Now in these problems, we aren't so concerned with what these formulas are telling us as much as we are concerned with how do we rearrange it to solve for something else, because that is a skill that we will be using this entire semester. So continuing on, we want to solve this formula for a, and we see that we have a couple of addition signs in here, and the first thing that we need to undo will be any addition and subtraction. In order to undo the addition of x sub I plus v sub I times t, we need to subtract both of those quantities, and whatever we do to the right hand side, we also have to do to the left hand side. So we're going to subtract an xi minus v sub I times t from both sides. When we do that, we are left with x minus x sub I minus v sub I times t is equal to 1/2 a times t squared. Now notice that there are more than one correct way to solve a lot of formulas, and we're just going to go through one way, but just remember that there's more than one way that you can do this. At this point, we still need to get a by itself, and now we see that 1/2 and t squared are both being multiplied by a. So in order to do that multiplication, we need to divide. Now the easiest way to do that, anytime that we have a fraction, so t squared divided by 2, we can think of this as, we can multiply by the reciprocal. So the reciprocal is basically just where we flip-flop the numerator and the denominator. So the reciprocal of t squared over 2 is going to be 2 over t squared. So we're going to multiply both sides by 2 divided by t squared. And then when we do that on the right-hand side, the 2 over 2 will cancel each other off. Same thing with the t squared over t squared. At this point then, we are left with 2 over t squared is equal to x minus xi minus v sub I times t, and that's all equal to a, which is what we were trying to find. Let's take a look at another example. So we're going to solve this formula for r, where r is the radius, and our formula, v is equal to 1/3 pi times r squared times h. This is actually the volume of a cone. And in this problem, we notice that there isn't any addition or subtraction, so we don't have to worry about that. We're going to jump right into the multiplication and division. So we can combine the pi times h divided by 3. We can multiply by that reciprocal. So we can multiply by 3 over pi times h on both sides. And when we do that, we have 3 divided by 3, so those will cancel each other off. And then we have a pi times h on top, same thing on the bottom, so those will cancel each other off as well. So in this manner, we are left with 3 times v divided by pi times h is equal to r squared. Anytime that we want to undo an exponent, in this case the square, we need to take the square root of the exponent to get rid of the square. So we're going to take the square root of r, and then we'll square root the other side as well. So again, the square root undoes the squaring, that exponent, and we are left with the positive or negative square root of 3 times v divided by pi times h. Now anytime that we take a square root like this, we need to include both roots, because if we were to square r, we could have a negative number here or a positive. But in this particular case, if r is the radius, it doesn't really make sense to have a negative radius, so we're going to get rid of that negative sign, and we are left with the square root of 3 times v divided by pi times h is equal to r. This concludes our video on how to rearrange formulas.